guys, I'm Jerry and this is Tony. Today we will talk about food chains and food webs.
And to clear up a common misunderstanding from the start, a food chain is not the same thing as a food web.
A food chain is used to show transfer of energy through organisms in one direction. Energy flow is simply the direction of which the energy is moving in. The arrows represent what the organism is eaten by. All actions require some usage of energy. Even as you digest food, some energy is exhausted.
A food web, in the other case, is a combination of food chains that show the connections between the organisms and how they maintain a balance. There will be more in-depth on this later. For now, we go over the roles.
To start, there are 3 roles called main trophic levels and 3 sub-roles in food chains. The food chain starts with the energy source. The energy source provides energy throughout the ecosystem. The most common example is the sun.
Okay, the first trophic level is producers or autotrophs. Producers absorb the energy fueled by the energy source, obviously. With a few exceptions, all plants are producers. Green plants are photosynthetic organisms. They are also known as photoautotrophs, as they use sunlight to create their own food. Autotrophs that get their energy from inorganic substances are called chemotrophs.
There are 4 things needed to make photosynthesis occur: chlorophyll, water, sunlight, and carbon dioxide. Photosynthesis is vital for life on Earth, since plants are all indirectly the main source of energy in food. There will be more in depth on this later. See what I did there?
Okay, the next group is consumers, which are known as heterotrophs. There are 4 categories of consumers, respectively the primary, the secondary, the tertiary, and the quaternary. Primary consumers take plant cells from the producers and convert it into their own energy. A better known term for these are herbivores.
Secondary consumers are consumers that eat primary consumers. Tertiary consumers are predators that eat secondary consumers. Quaternary consumers eat tertiary consumers. The term quaternary consumer is rarely used, however, as food chains and webs don't usually get past tertiary consumer. Animals that eat other animals are called carnivores, and animals that eat both other animals and plants are called omnivores. There are even more subcategories in consumers like insectivores,
Consumes insects,
and bacterivores.
consumes bacteria, obviously. Hey guys, so last but not least are decomposers and scavengers. Decomposers are also known as detritivores. Decomposers and scavengers feed on the tissue of dead organisms, using them for their own growth. This process obtains all of their nutrients, energy, and carbon.
For clarification purposes, we will now show you an example of a food chain. And our food chain commences in Tony's backyard.
Yay!
Our first trophic level is producer. In this case, it would be grass. Moving on to our first order consumer. Ta-da! You see Mickey Mouse happily eating the grass. Then moving on to our second order consumer.
Jerry Catty Yin! We suck.
Okay. Then we move on to our tertiary consumer, Teddy.
The polar bear
Let's pretend that teddies and cats live together.
in Southern Ontario.
So that commences our food chain. That ends our food chain. Yeah. Decomposers in this case would be worms. I don't want to look for one right now.
Hey guys, we're back and we're here to discuss another representation used to show the energy flow in the habitat. Food pyramids, yay!
And they're not the food pyramids America uses to stay skinny, or relatively average. But the two have a similarity in overall structure. As it ascends upwards, the quantities are smaller. Here is our constructed masterpiece.
Da 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 da.
Okay, go.
Basically, as you can see, there's more aquatic life at the bottom of this pyramid. Let me inform you first, there are two types of plankton, zooplankton and photoplankton. The photoplanktons are equivalent of the green plants that provide for us oxygen and food.
They make their own food with the same process of photosynthesis, turning sunlight, carbon, and oxygen into glucose and other simple sugars, as well as making their molecules edible to the other sea creatures. Zooplankton are simply the animals. They either eat photoplankton or other zooplankton.
So the small crustaceans here eat the photoplanktons, and the herrings eat the crustaceans. The mackerel eat the herrings, and the awesome shark eats everything below. As the food pyramid progresses upwards, less and less energy is available to the animal above it. Therefore, less of secondary consumers and even less tertiary consumers.
For reminders, let's fill in the roles in this food pyramid. Okay, class. Today we'll be inserting the roles of a food chain into a food pyramid.
Aww.
Guys, shut up. Okay, Benny, so where would the role of producers go?
Just put it with photoplanktons or something.
Okay, wow, Benny. Tony, where would the role of primary consumer go? Okay, wow. I like your enthusiasm. Jerry, where would the role of secondary consumer go? Okay, good. Where would the role of tertiary consumer go? Benny? Tertiary or third level. Thanks, Benny. Jerry, last but not least, quaternary consumer. Awesome! Oh, finally. I mean, class is dismissed, guys. Good job, everybody.
Yay, let's get the heck out of here.
And we're back for more exciting news! Now we will talk about transfer of energy. Transfer of energy occurs in a habitat either when a heterotroph consumes another heterotroph or a photoautotroph, or when a photoautotroph absorbs energy from the energy source.
However, remember people, there's no such thing as an organism that receives all of the energy from the organism it just ate.
When a consumer eats another consumer, energy is lost through heat. When a consumer eats a producer, energy is lost since much of it isn't eaten. In the science world, there's a rule called the 10% law. Only 10% of the energy from one trophic level is transferred to the next.
Okay, thanks, bye.
The total mass of organic matter at each trophic level is called biomass. In a way, biomass is another word for potential energy. Energy that is waiting to get eaten and used. However, the energy transfer is very inefficient due to the 10% law.
Okay, for example, the sun gives out 500,000 units of radiant energy. The photoplankton gives out 10,000 units of potential energy. The small crustaceans give out 1,000 units. Herring give out 100 units. And mackerel give out 10 units. And shark only 1 unit.
Our final topic, the ecological pyramid.
Finally.
Basically, the ecological pyramid shows the amount of energy in each trophic level. This pyramid, similar to the food pyramid, shows which trophic level has the highest level of energy and which level has the lowest level of energy. Tony?
Okay, for example, producers at 100%, primary consumers at only 10%, secondary consumers at 1%, and tertiary consumers at 0.1%. Okay, thanks, bye.